this video, I will concentrate on absolute value inequality. I'll solve problems and then I'll reveal the solution to the common mistakes of students. The absolute value of a number a is written as, and it represents the distance between a and 0 on the number line. So let's say you have a number line. This is a number line where this point is 0 and then this is a. The distance between 0 and a is represented as its absolute value. Notice that if it is n distance away, let's say from this point to this point is represented as n, note that minus a will also be represented as n, and that's why the absolute value of a is the same as the absolute value of minus a, and it is represented as the distance between a and 0 on either sides. Okay, so let's say I have minus 3 now. This is 0 and then this is minus 3. This is minus 3 and this is supposed to be plus 3. Notice that the answer to an absolute value problem is in unit or point or interval. So plus 3 is 3 intervals away. This is 1 interval, 2 interval, and then 3 interval. So it is 3 interval or 3 units away from 0. So the same thing applies for minus 3. It is 3 intervals away from 0, and that's why the absolute value of 3 is the same as the absolute value of minus 3, and is the same as 3 because it is 3 units away from 0. So let's say you have absolute value of x less than 4. Now if you are given this kind of inequality, what they want you to find are the values of x whose unit away from 0 is less than 4. That is, the absolute value of a number x is less than 4. There are lots of numbers whose absolute value are less than 4. So let's see. These are numbers, these are values of x in which their units away from 0 is less than 4. Okay, we can find 1 in that interval because 1 is 1 unit away from 0, is not up to 4. We can find 2 in that value. 3 is also part of the x, but 4 is not part because it is less than. So the units away from 0 or the intervals away from 0 or the points away from 0 has to be less than 4. 4.99 is part. 3.99 is part, but 4 points, 4 on dot is not part. So we can represent it. Also note that minus 1 is part, minus 2 is part, minus 3 is part, and then minus 4 is not part. So we can represent this on the number line as something of this nature. Not shading this circle, if I do not shade this circle like this, the way I leave it unshaded, it means that 4 is not part and minus 4 is not part. So we can write the interval notation for this as minus 4, 4. That is, it ranges between minus 4 and 4. I can also write it as this: x greater than minus 4 and x is less than 4. So this is another compound way of writing inequality of this nature. The same way, if you have something of this nature, absolute value of x greater than 4. Now, what this actually means is that you want to find the values of x in which their unit away from 0 is greater than 4. So what are those values? We can find that this is 0, okay, 1, 2, 3, 4. So starting from 4 upward, like 5, the unit away from this point is actually 5, which is greater than 4. So 5 is valid, and 4.99 is valid because it is actually greater than 4. Okay, their unit away is from, is valid. So the circle will not be on 5, the circle will be on 4. Okay, so because it actually starts from 4 upon, but 4 is not included, and that's why I'm not shading the circle. So as from this point onward, their distance away from 0 will always be greater than 0, will always be greater than 4. So I have -1, -2, -3, -4. Okay, onward. So -5 is also part because its distance away from 0 is more than 4 units. Okay, so that's what it means. So I can write this as x greater than 4, or x is less than -4, because actually this region is the region of less than -4, and then this region is the region of greater than 4. But notice that I used or in this case, and I did not write it like this. Writing it like this means I'm using and. Okay, now the reason for the and is that the value of x satisfies this condition at once, at a point. So if I pick up a value in this region, let's say I pick any value, -3, this -3 is greater than -4, and this same -3 is less than 4. But if I pick a value in this region, let's say I pick 5, 5 is greater than 4, but 5 is not less than -4. As a result, we use or when the regions are separated, and then we use and when the regions are at a point. Okay, so that is it about less than and greater than. Let's say there is an equal to. Let's say you have absolute value of x is less than or equal to. You just need to shade this. Now what that means is that 4 is also part. 4 is included and -4 is included. The same part, the same thing here. It means that -4 is included and then 4 is included. Now let's say you have a question like this. Okay, let me get rid of this space. Let's say you have something of this nature. Absolute value of x is less than -5. Or you have something of this nature, maybe 7x minus 10. Absolute value of 7x minus 10 is less than, let's say, -2 or -1. Now what this means is that you need a value of x for this question. Now for the first one, what it actually means is that you need a value of x whose unit away from 0 is less than -5. That is, its unit away from 0 is negative. It's impossible, okay, because the unit away from x will always be positive. It's a distance. You understand? It's a distance and it cannot be negative. So let's say you have 0 right here, and then you have a value at this point, let's say b. and then you have another value at this point, let's say minus b. It can be a negative value unit. You can have a negative value as the distance away from 0. It will always be in points or intervals, okay, or units. So it can be, let's say this is, okay, 1 2 3 1 2, okay, let us have one more unit so that it will be balanced. So it has to be 1 2 3. So interval 1, interval 2, interval 3, interval 4. It has to be 4 units, not 4 unit, not minus 4. So the absolute value that explains the reason for the fact that absolute value of a number cannot be negative. So this, anytime you have something of this nature, the answer is no solution. There is no solution because the absolute value of a number cannot, it can never be negative. It can never be less than a negative number. It will be greater than a negative number. When it is greater than a negative number, it means that it is positive, and this will be valid. Okay, if you have something of this nature greater than minus 2, so what they want you to find are the values of x whose unit or whose interval away from 0 on the number line is positive. Notice that all real numbers, all numbers on the number line, they have absolute values that are positive. Okay, all numbers on the number line, they have positive distance away from 0. Okay, so it means that whenever you have something of this nature, the answer is all real numbers. Real numbers are numbers that can be found on a real number line. So all real numbers, all the numbers of the on the number line, we have the absolute value greater than minus 5. Then we have the absolute value greater than minus 2, because actually greater than minus 2 means positive. So that's the way it is. So if I pick up minus 3 now, the absolute value of minus 3 is greater than minus 2 because it is positive. So all real numbers, you just need to shade all. Let's say this is minus infinity and this is positive infinity. So you just need to, all real numbers on the number line will be represented as this. Okay, so you can represent all real numbers on the number line as this, putting an arrow right here and then putting an arrow right here. Okay, that means you are going from minus infinity to positive infinity for all the real numbers. Okay, so let's solve some practice problems. Sometimes you may be asked to convert something of this nature into a modulus form. So let's say you have an inequality, a compound inequality like this. Notice that anytime we have something of this nature, it is something of this kind. Let's say this is y. It has to be less than. No, remember I told you, but if we have something of this nature, it has to be or, that is x greater than y, or x greater than y, or x less than minus y. But this will be x greater than y and x less than minus y. Okay, so that's the way it is. Now let's say we have something of this nature. No, this is supposed to be something of this is supposed to look like this, right? So if you have something of this nature, we just need to first of all make use of the 6 right here and the 0 by adding them together, which will be 6, and then we need to divide 6 by 2, because what we are looking forward to is that we are looking forward to a point. Okay, That means by getting this 6, it means the distance, the addition of the distance on both sides of x will be 6. So we just need to divide by 2 to have a sense of the number, the units away from 0 on either side. So this has to be 3, and on either side has to be 3 as well. So we'll have something of this nature, 3 right there. So I'm looking forward to having -3 and +3 on both sides. Now to get that, I just need to add 3 to both sides. Whatever result I get right here, I need to add it to both sides of the inequality. So I'll have -6 plus 3 less than x plus 3, then less than 0 plus 3. So I'll have something of this nature: x plus 3 greater than 3, and then greater than -6 plus 3, which is supposed to be 3. So this is the inequality. Since I now have, which is supposed to be -3, since I now have this, now remember that what this actually means is from this. Okay, that means I'll have absolute value of x plus 3 to be less than 3. Okay, so of course the absolute value of x plus 3, if it is less than 3, you will have something of this nature. So that's how to convert, to write an inequality in a modulus form, or we can write a compound inequality in form of an absolute value. Alright, let's have one more. Let's say you have something of this nature: x less than -1 or x greater than 4. So the same way, we have 1 right here, and then we have 4 right here. That's supposed to be 5, and of course we'll have to divide 5 by 2, okay, so that we can know the number of units on each side. That's supposed to be 2.5. Okay, so I need to add 2.5 to this inequality right here. Okay, just like I added in the first problem. So if we do that, we'll have x plus 2.5 less than -1 plus 2.5, okay, or x plus 2.5 greater than 4.5. So if I do this very well, I'll have x plus 2.5 less than -1 plus 2.5. That's supposed to be, okay, so we'll have something of this nature: -1 plus 2.5, that's supposed to be 1.5, or x plus 2.5 greater than 4.5. Notice that it will be impossible for us to get this absolute value in this manner, because we do not have the same value at this point, right here, okay, and at this point. We need to have the same value, just like we had the same value right here, so that we'll be sure that that is the distance away. You see, we need to have the same value, just like we have y right here and -y right here. So in order to adjust, you see, what we're actually doing is to adjust our values so that it will be able to meet up to the modulus. So in order to do it, starting from this point, we need to start from this point always. Okay, starting from this point, since I have 2.5, so I already have it in mind that what I want to adjust has to be 2.5 away from both sides. So I'll be thinking of -2.5 and then +2.5, just like I have -3 right here and then +3 right here. Okay, so in order to get that, I will need to let me get rid of that space. So what I just need to do is that I will subtract these values. Okay, these values right here, I will need to subtract them from the points, from this value minus 1 and 4. Okay, so I'll have something of this nature: minus 1 minus 2.5 for that point, and then 4 minus 2.5, so that I will have something of this nature: minus 1 plus, this will be plus, minus 1 plus 2.5, that's supposed to be 1.5, and then 4 minus 2.5, that's also supposed to be 1.5. So the balance point is 1.5 away. So I'll have something of this nature. I will just need to subtract 1.5 from this inequality. So I will have x minus 1.5 less than minus 1 minus 1.5, or x minus 1.5 greater than 4 minus 1.5. So if you do this correctly, you should have something of this nature: x minus 1.5 less than minus 2.5, or x minus 1.5 greater than 4 minus 1.5, which is also 2.5. So since we now have the same thing on both sides, so that's how to get the same thing on both sides. Having gotten this, you just need to do this step as well. This is a very important step for you. So we just need to subtract this from the end point that we have here, minus 1 and 4. Okay, so that's supposed to be 4 minus 2.5. You just need to subtract these points from the end point. So we are going to have minus 1 minus 2.5, then minus 1 minus 2.5, that's for this, and then this other one 4 minus 2.5, so that you will have a balanced point. So we'll have something of this nature: magnitude of, the absolute value of x minus 1.5 is greater than 2.5. I use greater than because I know that it is greater than that makes use of all. Okay, so what this actually means is that x minus 1.5 is greater than 2.5, or it is less than minus 2.5. So that's how to do something of that nature. Now let's say you have a square value as well. Let's say you have something of this nature: x minus 2 squared being less than or equal to 4. So if you have something of this nature, x minus 2 squared less than or equal to 4. Now, anytime you have a square, you have to be very careful because what it actually means, let's say you have x squared equal to a particular value, let's say y. It means that either the positive value of x is being squared, you will have y, or if you have the negative values of x, if you square it as well, you will still have y. That's what it means. Like say plus 2 squared is 4, the same thing minus 2 squared is also 4. That means plus or minus 2, I mean that means plus or minus 2, if you square that value, you will have the same value 4. It means that the absolute value of 2 when squared will still be equal to 4. What this actually means is that the absolute value of x minus 2 squared is still less than 4. So we can find the square root of both sides. which will become x minus 2 squared, then the square root less than or equal to square root of 4. The square root will always cancel the square, so that we have the absolute value of x minus 2 less than or equal to 2. So this is it. This is the value. Okay, so let's solve, friends. Let's solve a different practice problem. So let's say you have a question of this nature: x plus 1 upon x, which is less than 2. If you have something of this nature, this is a rational inequality, and of course it has an absolute value. So the first thing to do is to interpret the absolute value inequality so that it becomes something of this nature: x plus 1 upon x less than 2. Don't forget this is less than, then greater than minus 2. So if we had greater than 2, for instance, if we had x plus 1 upon x greater than 2, then you know what to do. That means it will become, by interpreting it, it will become x plus 1 upon x greater than 2, or x plus 1 upon x less than minus 2. So it's as simple as that. Then the next thing to do will be to solve for the different inequality value. So let me pick x plus 1 upon x less than 2. Then we find the solution to this inequality, and then we solve for the other one: x plus 1 upon x greater than minus 2. Okay, so to solve this, you can check my video where I solve problems on rational inequality. This is an example of a rational inequality. Okay, so the first thing to do is to bring 2 to this side of the inequality. If I do that, I will have x plus 1 upon x, which is minus 2, and then less than 0. Okay, if you take 2 to this side of the inequality, it becomes negative. So if I find the LCM, I'll have something of this nature: x, then x plus 1 minus 2x, which is actually less than 0. So x minus 2x, that's supposed to be minus x plus 1 upon x, and that's less than 0. So we have two factors right here: minus x plus 1 and then x. So the end point, we need to find the end point of those factors by equating the factor to 0. Okay, oh, this is supposed to be 1. If I equate the factors to 0, I'll get their endpoints. Alright, so this is supposed to be, if I make x the subject of the formula, I'll have x equal to 1. Okay, a positive value of 1. Now I need to equate the other factor to 0, which is x equal to 0. Alright, so the endpoints that I have right here, I have 1 as the endpoint and I have 0. So let's say 0 is right here and then 1 is right here. So these are the endpoints. Endpoints are the end of the intervals, the range of values. Notice that the answer to an inequality problem is in range of values, unlike equality, which deals with an exact value. So this range is x less than 0. This range is x greater than 0, but it is actually less than 1. And then this range is x greater than 1. Now we need to know which of the ranges will satisfy this inequality. This is less than, and less than actually means negative. So we want to know which range of x will be negative. Okay, how do we know that? We will know that by testing their values. If I test the value, any value in this region, If it gives me 0 less than, if it gives me a negative value that is less than 0, then I will know that that region satisfies the inequality. So let me pick a value in this region. Let's say I pick up -5. If you substitute -5 right here at the numerator, that will be -5 plus 1. That's supposed to be a positive value at the numerator. Okay, divided by, if I put that same -5 at the denominator, I'll have minus, so that means I have a negative value at the denominator. So plus divided by minus, that's supposed to be minus. So that means this region gives me a negative value. That means this region satisfies the inequality. Now let me test for the other region, x greater than 1, this region. If I pick up a value in this region, I may pick up 7. If I substitute 7 right here at the numerator, I will have -7 plus 1 upon 7, which is actually minus at the numerator, and then a positive value at the denominator. Minus divided by plus is actually minus, so I have a negative value for this region as well. So that means this region satisfies the inequality. Notice that this region would, however, not satisfy the inequality. So let's say I pick up a value in this region. If I'll pick up a value in this region, I'll probably pick up the numbers between 0 and 1. That's supposed to be 0.5. Okay, that's half. If I pick up half, if I substitute half into x at the numerator, then I'll have something of this nature, minus 0.5 plus 1. And of course, that's supposed to be plus half. That's a positive value at the numerator. If I put that same half at the denominator, I will have a positive value. So positive divided by positive, that's supposed to be positive. So it means that this region does not satisfy the inequality. So the answer to that, to this part, the answer to this part of the problem is x less than 0 or x greater than 1, because this is the region. Okay, alright, so for that answer, now let's solve for the other part of the problem. X plus 1 upon x greater than -2. So I need to take -2 to the other side so that I'll have something of this nature. Oh, I'll have x plus 1 upon x, then I'll have plus 2 greater than 0. So by LCM, I'll have something of this nature, x as the LCM, and then x plus 1 plus 2x greater than 0. It is just like having something of this nature, a upon b plus c upon 1. What I will have is this a plus cb. So that's actually what I did right there. Alright, so if I continue, x plus 2x, that's supposed to be 3x plus 1 upon x, which is actually greater than 0. Okay, so I have two factors, so I need to equate the factors to 0. If I equate 3x plus 1 to 0, I'll have x equal to -1 upon 3. If I equate x to 0, then I'll still have 0. So I have two endpoints now. I have the point where x is 0, and I have point where x is equal to -1 over 3. So the region, -1 over 3 should be right here, -1 upon 3, and 0 should be here. So this is x greater than 0, this is x less than 0, but x is greater than -1 upon 3, and this is x less than -1 upon 3. Alright, so if I pick up a value in this region, let's say I pick up 5. If I pick up 5 and I substitute into the numerator, I'll have 15 plus 1, which is a positive value, and then I'll also have a positive value at the denominator. That means this region satisfies the inequality, because the inequality wants me to find a positive value which is greater than 0. If I pick up a value in this region, let's say I pick up minus 7. If I substitute minus 7 at this point, that's 3 times minus 7, which is minus 21 plus 1. That's a negative value. At the denominator, a negative value, because I'll be substituting minus 7 as x. So minus divided by minus, that's supposed to be positive. So this region also satisfies the inequality. Then this region will not satisfy. So the answer to this inequality is x less than minus 1 upon 3. That is this region, and then this region, x greater than or x greater than 0. So that's it. You can check my other videos as well for inequality problems. A compound inequality of this nature, minus 3 less than 2x less than 5. Let's say you want to write this in the modulus form, or you want to write this in form of an absolute value. So the first thing to do is to make sure that x stands alone, so that you will have an exact value for x, so that if you divide through by x, by 2, you will have minus 3 upon 2 less than x, then less than 5 upon 2. I'll pick up 3 upon 2 plus 5 upon 2, and that's supposed to be 8 upon 2, which is equal to 4. So if I have 4 as the total number of the distance on both sides, so I need to divide 4 by 2. That's supposed to be 2. So I already have a sense of having two units on both sides. So I have this in mind already. You know, this is 0, and then two units. That means this is plus 2, and then this is minus 2. So what I just need to do is making use of this inequality right here, so that I'll have minus 3 upon 2 minus 2. I just need to subtract this point from this point, and then this from this, so that I'll have 5 upon 2 minus 2, in order to get a balanced point. So if I do that, this is supposed to be minus 3 upon 2 plus 2, and then this is supposed to be 5 upon 2 minus 2. So 5 upon 2 minus 2, that's supposed to be 5 minus 4 upon 2, okay, which is supposed to be 1 upon 2, that's plus half, and this is supposed to be minus 3 plus 4, and that's supposed to be minus 1 upon 2. So I already have a balanced point. Since I already have a balanced point, which is minus half and half, I just need to add it, subtract it from this inequality right here, so that I'll have minus 3 upon 2 minus half less than x minus half, and then less than 5 upon 2 minus half. So the essence of doing all that I have done right here is to arrive at a balanced point, which is minus half and half, just like the way I solved for the other problem. Okay, so that I will have something of this nature: minus 3 over 2 minus half, that's supposed to be minus 4 upon 2, and then x minus 1 upon 2, then 5 upon 2 minus half, that's supposed to be 4 upon 2. So that we'll have something of this nature: minus 2 less than x minus half less than 2. So it means that the absolute value of x minus half is less than 2. I'll make use of this value, the first value. So this is the answer to the problem. So the first thing to do is to make sure that x stands alone. So if x stands alone, then you had these 2 points, 3 upon 2 and 5 upon 2, without the negative sign, which will give you a particular value. That value divided by 2. This value gives us the symbol that the absolute value we need, the total distance on both sides away from 0 is 4. So we need to get a sense of each side. So each side will be 2. That's why we are dividing by 2 on each side. The next thing to do after we have gotten these 2 is to subtract it from these points, that same end point, and at that point we will consider their figures, their signs. Okay, we'll consider their signs right here. Don't forget this sign as well. So we'll consider their signs so that we'll be able to get an exact point. So after getting the exact point, we are done. We just need to subtract it throughout the inequality. So that will give us the exact point, the exact absolute value. So that's how to generally deal with absolute value inequality. Thanks for watching. Do share with your friends and subscribe.